right, now he's lost me my presenter view, so I have no idea where I am. Let's see if we can get that back. Everything's working. Yay! So thank you for the introduction. Now you know what I do in Python, but what I'm going to talk about a little bit more today is what I do in my day job. So when people ask me what I do in my day job, I do tell them that I break things and tell people no, but I'm an open source security researcher. And sometimes that means people's eyes glaze over and they go find someone else at the party to talk to. But for a lot of people who are in open source, people are very curious about security. They have questions. What sort of training did you need to become an open source security researcher? What makes open source security different from closed source security? How do you not go crazy? Somewhat debatable whether I am or not. But the one that I hear very frequently from open source people is open source software really more secure? We have this reputation, we want to, you know, be rah-rah, we're the best. But is it true? From closed source people, I often hear it the other way. How could a bunch of random open source hippies on the internet possibly be making quality, secure software? But usually open source people, we're willing to believe, we're hoping. So I want to be able to say yes and just walk off the stage, but Kushal wouldn't have made me fly all the way from North America just for that. So as you might have guessed, the question's a little bit more complicated than that. So my background is in academia. So I have a master's degree in artificial intelligence. I have a PhD in web security. My undergrad is in mathematics. I spent a lot of time in school. And when you're working as a researcher, you get really excited about questions that don't have an easy yes or no answer. That's the sign that you're on the path towards expanding knowledge, right? Or at least you're on the path of something interesting. Now, a lot of these questions are things that could lead to PhDs. This is probably one of them, and I don't have the answers. But hopefully, I'll be able to tell you a little bit about the problem, why it's interesting. So, why is this a hard question to answer? I mean, surely we have some way to tell whether things are secure, and we know lots of open source software. We can just like test, and we should be able to throw all these things in a box and get an answer. And it's a little hard because we don't really know what it means to be secure. We have a lot of metrics. They don't always tell us what we really want to know. I like to say that measuring security is a little bit like measuring intelligence. So when you measure intelligence, you do things like taking tests in school, doing IQ. One way that people often use to measure is your education level. How intelligent are you is reflective of how many degrees you can accumulate. So by that standard, I am so smart. I am awesome. And that's good enough for some things, right? Like that's good enough to get me a work visa in the US. It's good enough to get me a job. But does that mean I'm really more intelligent than someone who doesn't have those degrees? I have a friend who dropped out of high school, joined a startup, and has been working for at least 10 years more than I did. And he is super, super well paid because he does an unusual job and he's really good at it. So by that metric, he makes probably twice as much money as I do. And I feel like I'm paid really well, but he makes a lot of money. Is my friend more smart than me? Depends on your metric. Now, I don't know if any of you have made much study in metrics for intelligence, but one of the things that I find fascinating about it is that IQ is actually really bad at predicting things. So I could say I have a high IQ. That doesn't really indicate whether I'm going to be successful in life. It actually doesn't even really do a good job of indicating whether you're going to be successful in school, which you would think, you know, the same sort of tests are being used, it would be obvious. But it doesn't work. there's a lot of other factors. The one that people usually bring up immediately is socioeconomic status. You know, if you don't have to work and you have a little bit more time to think about things, you tend to be a little bit more successful. But the one that I think is most interesting to us and most interesting to this conference is that community. Your communities are a much better predictor of your eventual life success than your intelligence. Because having a good community means you have opportunities. Doesn't always mean you take them, but it means they're there if you're willing to move on them. So keep that in mind. We'll go back to it. But let's go back to security. So there's a bunch of really common security metrics. The very easiest one for everyone to understand and to everyone get data on is the number of publicly known vulnerabilities that a product has. So security has this large database, they call it the CVE database for common vulnerabilities and exposures. It's a list of all known public bugs, or at least all known filed correctly public bugs for any given product. And if I were trying to just convince you that open source is awesome, I'd probably show you something like the graph that I've shown half on the left there, where you can see that Microsoft, and this is real data from the CVE database, you can see that Microsoft has like a bazillion more security bugs year over year, except for just this year over Linux. So therefore, closed source sucks, open source rules, we're done. But, and I hope you're all skeptical. You should always be skeptical of things I tell you. I'm a security researcher. One of the things I do is social engineering. So if I'm trying to lie to you convincingly, and I think you're a crowd of people who are into open source and willing to believe that open source is better, I'm just going to give you something that looks kind of reasonable and fits your existing mental model. And this is called, this is a brain flaw, a bug that we all have that lets us use confirmation bias and says, I've got a theory, everything that confirms my theory, I'm willing to accept without thinking about it too hard. But we should think about these numbers a little bit harder. Like, what products are under the Microsoft label in the CVE database, and what products are under the Linux label? How many products are under each of them? I can tell you that there's a lot of Microsoft products. Or, if you're thinking a little bit more cleverly, you'll note Microsoft is sponsoring this conference. Are all of those products under the Microsoft label actually closed source? No, they're not. They produce all kinds of interesting open source software. So that's the straight numbers. Okay, so maybe we could divide it by the things that are in the category and get sort of a nice scaled number. Would that help? Well, you know, this little chat client that I wrote versus the entire Linux operating system, that's a lot of different lines of code. Maybe I need to scale it based on the lines of code. Or this product that just released last year, is it going to have as many bugs as Windows 95? Well, obviously not. So do we need to scale it based on the time? So this is a really easy metric to get. It's really useful for telling you how you're doing over time in a given product. It's a little less useful for comparing different things. So once people realize, okay, that one's not perfect, they think, well, maybe we could sort of look at how severe the issues were, right? So like Heartbleed taught a lot of people about bug marketing, for one thing, but also about, you know, issues being bigger, issues being really well known, issues being exploited all over the place. One Heartbleed is probably worth a bazillion minor denial of service where your web app falls over. But is it 1 million or is it like 500? Or how do you scale these things? Well, how do you make these numbers match and be a meaningful thing? And then on top of that, how are people reporting them? So a friend of mine who used to work in enterprise software commented that one of the things that drove him crazy about reporting bugs internally was that they had different rules. So if it was a P1 bug, then it had to be fixed by this time. It had to be done right away. You needed to have a senior engineer on it. And so if you wanted your bug to be fixed in this company, you'd mark it as a P2, and then you just sort of talk to the right person. It's not that severe, but we should get this fixed so that it doesn't delay your release. And it was all social engineering. So even if we have a severity number, how objective is that? Anytime someone tells you they have a completely objective measure and they're not like doing temperature, you should be skeptical. Another one that's pretty popular is how long is something been vulnerable? So like Heartbleed had been around for a while. How long has it been out there? How long has it been exploited? How fast did you fix something? So this is a quote from a news article in 2008. And the news article ran with the headline, something about IE trounces Firefox on security, because IE didn't have as many bugs as Firefox. Right back to that first metric. But when you dig into it, they said, well, actually, Firefox fixed more of their bugs, and they fixed them a lot faster. The shortest patch time in IE was 85 days. So that's like a lot of a year where that thing was known, and they're talking about 0 days, so probably that thing was actually being exploited, and we didn't have a fix. So which browser is really more secure? Is it Firefox? I like to think it's Firefox. I use Firefox. But you know, maybe that's my confirmation bias talking, that I just want to believe that it's true. So those are three metrics that are commonly used. There's other ones. There's lots of other factors you can take into account. But the reason those ones are used are because we can calculate them. And we have the data, and it doesn't take hundreds of hours of a security researcher's time to say, well, how do I feel about this? Did they respond well to this bug? So these are the ones that are used. They're kind of crummy. But even if we had a magical oracle that said, I know exactly how secure this product is, it's 80% or something, we still couldn't answer this question. So the next part of the problem is that when you're talking about open source software, you're not talking about one thing. You're not talking about 10 things, 1,000 things. You're talking hundreds of thousands, millions of tiny little things, and millions of really big things, and everything in between. And when it comes to releasing an open source product, it's not like anyone has a bar where your product must be at least this secure before it goes out the door. When I release code at work, we actually do have a bar. So if I work at Intel, and before something goes out, it has to pass a little checklist of things, and I have a pretty good idea that it's safe enough, depending on what it is. But even then, even if we were talking about proprietary companies, everyone has different bars. So when we talk about the security of software, we're talking about something that's a population that looks kind of like this. So those of you who have been in university recently will probably recognize this as the normal curve. It's usually what we use for grades. It's a really common probability distribution, and we use it because it's good enough to explain a population of things. It's got some neat mathematical properties that I'm sure you don't want to hear about. But when it comes to security, I'm doing better than a random guess on this. I actually have a lot of experience looking at different products in a little bit more depth to see how I feel about their security. So, as I said, I work at Intel, and as a product security researcher, I support our open source teams when they're trying to make a new product. So it's a bunch of different things that I do. I work with the teams to explain security concepts. I do code review. Sometimes if they don't agree that something is a problem, I write an exploit and prove that it is. I do training. It's all really interesting stuff, and you should totally ask me about it later. But one of the things that we've started doing is reviewing all of the open source packages that our engineers want to use in software that we're going to release. And this is a Herculean task. It's terrible, but it's really interesting. So in the past year and a half, I've reviewed about 300 packages, and I mostly get the packages that are related to the web, because my PhD is in web security, or packages that are related to Python, because I get to use my existing knowledge of Python, and so you can give me a package and I can say, oh yeah, I know those people, they're great, this will be fine. So it allows you to shortcut a little bit because I know the communities and I know the people involved and I know how quickly they respond and how much they care about security. My whole team, which is maybe a dozen people across the world, has looked at about 3,000 packages and has shared a lot of data with each other, showing which ones are good and which ones are bad. So if we're talking about a curve, something like Django, well-established open source project, cares about security, has a lot of people with some experience in that area, it's going to be pretty high up there. And most of the packages that are up at that end of the normal distribution are things you're going to recognize. Lots of Apache products, things like Python itself, even other languages like PHP. PHP inexplicably has a really great test suite, so they don't have a whole lot of regression bugs, which is neat. On the other side of the curve, you have little tiny projects. So, you know, the first web app I wrote, if I had put it online as open source as opposed to, you know, doing it in a proprietary company, would have been over on the other side. I didn't know as much about security. No, I didn't have a whole team of people to help me, and it was probably okay, but it's not like enterprise quality software, which maybe some people think is an oxymoron, but it's not really great quality software. Most of open source falls in the middle. So probably about 50% of the packages we review are sort of okay. So that means you've got a bug tracker. If I reported a security bug to you, you'd probably fix it eventually, and it might take a little while. So that's sort of good enough for a lot of things. But you know, you get to a smaller product and then it takes longer to fix, or you get to a product where people actively don't like getting security bugs and they ignore them, and so you sort of get the whole spectrum. But we've got about 50% in that middle where you accept bugs, you fix them sometimes. You've got some good stuff at the top, and the stuff at the top is, so I'm only looking at packages that people want to use in our software. So I'm probably looking at slightly better, skewed a little bit better than average packages. But we have probably 40% are actually really good, and I'm willing to just sort of trust that the developers will do the right thing. And then that last 10% are like the crummy Node.js packages that are one line long. Nobody has touched it since 2013, and it has 12 bugs, all of which sound terrifying. I don't want to pick on Node.js, but anything that makes it really easy to upload little like one-line packages is just a repository of crap. We call it a crapacopia. PyPy also has this problem. It's very easy to upload something and then never look at it again. That's not going to get you secure code. So I haven't looked at nearly as many non-free packages. I do review some internally depending on what they need. But I do see some when they're ready to make the leap to open source. It's not really enough data for me to draw a conclusion. But my intuition is that they're going to be just, the average is a little lower. And the reason for that is mostly that a lot of them don't have a good way for public people to report bugs and don't have experience just saying, oh, thank you for the bug, we will fix it sometime. So a lot of them are just sort of, you throw the bugs into the abyss and nothing happens, or you throw the bugs in and they're like, so for $100,000 we can get you a support contract. So I would guess that on average they're a little less secure. So I've spread these out a little bit. I think they're actually very, very close together, but it would be very hard to see on the slide. So hopefully, you can sort of see what the problem is here. If I'm trying to answer the question of whether open source is more secure or not, and the averages are pretty close, that doesn't really tell you much. I mean, most of those packages are all in the same blah in the middle. And only a few of them are like really excellent and shining and amazing, and you should always use them. So I haven't really answered the question. But worse than that, is that even the question I really care about? Do I care exactly the magical metric of security right now? No, really what I care about is this a package I should use? Will this package be secure from a year from now? Is this package going to be a maintenance nightmare and I'm going to be re-releasing my software every 2 weeks because OpenSSL updated? And I can't really answer the question of should I go with open source or should I go with this proprietary thing that I can get a license on, because it depends. It always depends. So how is this useful? What should I choose? How am I going to make a decision with this data? The other thing is, so when we're trying to answer what it's going to be like in the future, we always have to remember is that security is a lot of work. Software is a lot of work. There's finding bugs, there's patching bugs, there's testing patches, there's doing proactive things to make sure we didn't introduce new bugs, there's documenting things correctly so everyone uses it correctly. It's a never-ending process. And the security part of it does require a few specific skills and knowledge. So the naive assumption, and one again that I hear a lot in enterprise software, is that it's all about resources. And a bunch of open source hippies could not possibly have the resources that are available to companies that can afford to hire security researchers, right? Hopefully you're all thinking, but didn't you just say you were paid to do open source by an enterprise company? So it's a false assumption. Like lots of companies, Intel, Red Hat, actually, if you ever look through the CVE bugs for Linux, you often find that there's a Red Hat person who found it or a Red Hat person who fixed it. They have a great team. HP, Canonical. We have lots of people who are paid to work in this space. So we can't make a decision based on that. So let's go back to intelligence. So we know that IQ is a kind of crappy predictor for future success. It's not getting us what we want. But we know that community is a good predictor. So probably you see where this is going. We've been harping on community for the past 2 days. But software is made by people. If having a good community is likely to make people more successful, shouldn't that translate to being successful at creating software? So when we're talking about what we would want to see in a secure community of people and people who can support security, one of the biggest things is openness. And this comes especially in the crypto world. So if you have a crypto algorithm and it's completely proprietary and you never tell anyone how it works, and you tell everyone that it's secure, people will laugh at you. That is ridiculous because it hasn't been audited by experts. It hasn't been tested by an independent body. You'll probably think it's good, but you know, there might be someone smarter than you out there, or there might be someone a little bit more dedicated. And so in order to ensure that cryptography is as good as it can be for the whole world, plus or minus some laws and regulations, what the security community does is everything is open, everything is discussed, everyone works together. And you hear this a lot in open source too, right? The whole many eyes makes all bugs shallow. It's something that's baked into our culture. And it's really important, not just for fixing an algorithm, but also for being open to knowing that there is a security issue. So we want a culture where it's okay for people to say, hey, I found this bug. looks kind of scary. What do we do? And have a good outcome there, as opposed to just a, yeah, whatever. Another thing that you really want to see in a secure community is collaboration. Obviously, we've been talking about this all week, too. So just like with cryptography, you need a community of researchers and mathematicians who can do the math, do the testing, understand things, implement things correctly. And you need access to people who can help you in stuff you don't know. So when I sit down at work, the guy on my right is a cryptography expert. The woman behind me breaks everything that we make. I look at web security and argue about it. Each of us has different strengths, and without the entire team of testers and people with kernel development experience and people with all sorts of different backgrounds in mobile and IoT, I wouldn't be able to do my job. Because there's a lot of times where I see this bug and I'm like, I don't know what that is. Like, the arrogance of PhD is that I'm supposed to say, oh, I understand everything, I'm brilliant. But that's not how it works. The important, we have this myth in tech about these like entrepreneur superstars who go it alone and trail a wake of people who just follow their lead and make the magic happen. But it's security especially. It's a team effort. You can't really go it alone and do nearly as good a job as you can with friends. So the women up on this slide, this was our open source security panel at Grace Hopper a couple of years ago. And these are all people who I met through being involved in open source, got introduced through. I wish I could show you the huge number of different security experts I've met over the years, the different open source people, but this is one panel of many. The other thing that I really want to see as a good quality to have in a security community is passion. But I put it up there with a question mark. And there's a reason for that. It's because I don't really like the word passion in tech, because it's a word that we tend to use to discriminate against people in technology fields. So, you know, the parent who has to pick up their kid from school and can't work 10-hour days, well, they're not passionate enough, so no raise for them. Or the employee who gets migraines and has to remember to stand up and get out of the fluorescent lighting and go outside for a bit in the middle of the afternoon, well, they're not sitting at their desk all day working really hard, so they're not passionate enough. It's terrible. It's stupid. Like, that has nothing to do with passion. That's just workaholism. Do not mistake having good boundaries with having a lack of passion. If that were true, none of us would even make it here. We'd all be sitting at our computer at home writing some code. So what I want you to focus on is something that we do talk about a lot as passion in open source, which is caring about getting it right. Caring about code quality, caring about users, caring about accessibility. That ability to think beyond just, I'm just writing some code, but to really push towards excellence and be willing to allocate the resources to do that, even if it's you're in your spare time and you just want to spend time arguing to make sure this PEP is perfect before we do anything. So I imagine you've all figured this out, but all of those things are things that we talk about in security. They're also things that we've been talking about all week in open source, and especially in Python. Like, Python is really great at being open, at being collaborative, at respecting passion in useful ways, and caring about what we do. And open source has really baked that into our culture, which means that I think we have the groundwork to be more secure. I don't know that I could ever prove it because I don't have the metrics, but I feel like we are standing on good, solid bedrock, and we are not slipping into the abyss. we have the chance to be really awesome. But just because we don't have, sketchy managers telling us to just get this thing out the door and don't worry too much about whether it's good quality code or not, doesn't mean we're done. Having a solid bedrock is just the beginning. There's a lot of hard work. I'll bet you all see where this is going. How can you help? So hopefully, all of you are passionate enough to be here. All of you are interested enough to be here. And I know that a lot of open source people are curious about how can we enable more security? How can we make sure that one day it'll be so obvious that we can say, is open source more secure? Oh yeah, oh yeah. Like, we don't even need a metric. We can just tell. So how can you help? So this is the simplest thing, and surprisingly, very infrequently done, is have a clear way to report security bugs. And the reason security bugs are a little different from other bugs is that sometimes you want to keep them private before they're fixed. So usually in open source, we want everyone to know what the bugs are so that we can deal with them appropriately. Sometimes for security reasons, you don't want someone to be exploiting a known issue in Django while people are trying to fix it. So the typical stuff would be, here's an email address, maybe a PGP key to sign it. Send us a thing. If you've got a slightly nicer bug tracking system, sometimes there's a way built in. And so those are pretty simple. And then the next step that, shockingly, a lot of companies are really, really bad at is responding well. Now, I have confidence that as Python people, you have a pretty good idea of how to respond to bugs. And part of that in Python is that we have this great community code of conduct that reminds us of what our community norms are, that you should be thoughtful of people's time and effort, and don't be a jerk when you disagree. So, you don't just throw it out. You try to see whether it's a real bug or not. So one of my favorite stories about responding to a bug really well was from Apache. And I'd been investigating a package for work as something that a security researcher had found a bug in, and one of my colleagues had asked, I want to use this package. Can you find out if this bug's been fixed? So I did some searching, and finally I just emailed the researcher who had found the bug and said, hey, I can't really tell from Apache's mailing list whether this got fixed or not. What's up? And I got the greatest email. He emailed me back. He said, oh yeah, we're totally working on that. It's going to be in the next release. But more than that, I'm so excited about my experience working with the Apache community because they've invited me to join their security team, and now I'm working with them on all kinds of other bugs, and this is really amazing. I was worried that no one would respond, but now I feel like I'm part of the team. And you can't always do that, but that was a really neat way to see that the Apache community really values security researchers and really values the effort that he'd put in and was willing to work with him not only on his own bug, but say, hey, you've got some good ideas. Now, if you're being a little cynical, you can say, well, you just rewarded his hard work with more work, which is true. But I think he was a grad student. That looks great on a resume, being part of the Apache security team, so he was really happy. Or if you want something easier to remember than thinking about the entire code of conduct, which of course you've memorized, right? No, I haven't memorized it either, but I like it. Something easier to remember is just send thank yous, not cease and desists. And it's really true that people do send cease and desists. Oracle, for example, made headlines last year when one of their people, someone very senior, claimed that filing security bugs was an indicator that you had violated your license agreement and you should just stop or there would be lawyers. So how do you feel about the security of Oracle as a result? I certainly don't feel like they're getting free security research from people. I certainly don't feel like anyone's going to report anything, and I kind of feel like if I found a bug in Oracle, maybe I'd sell it on the black market to make them look really bad. I wouldn't, I promise I wouldn't. But a lot of people would, right? Like, it's kind of a waving a red flag in front of a bull. When you go in and you say, that's not a security bug, leave. It's like, that researcher is like, oh yeah, bring it. And people will spend a lot of time to prove you wrong. So, don't be that person. Try to be polite. Don't treat them like loaded time bombs, but also, Okay, so those things are great. Those are things that anyone who's involved in a software community can do, and they're things that I wanted to highlight because we often forget them in the chaos of setting up our bug tracker and everything else. But I know, because I've talked to a bunch of people at this conference already, even though I'm the least popular speaker because I'm last, so you had no idea what I was talking about. I've already talked to people, and you don't want to just, like, attract the talent or work with the talent. You want to be the talent. You want to have that, like, I am an open source security researcher, I am all powerful, I am going to, like, get the cool work visas and get the cool jobs, and everyone is going to want me, and my name will be in lights across open source. Okay, so, obviously my name's not in lights, but I do have a really excellent work visa in the US. I now have a green card, but my old one marked me as an alien with extraordinary abilities in the sciences, which I swear makes me feel like Spock. But it is an indicator. They literally filed 200 pages of Terri is really awesome and America needs her to be here. I'm Canadian, so this is not a thing that you would otherwise assume. But, but yeah, so these are really valuable skills that maybe you would like to have. Maybe you're earlier in your career, maybe you just want to know about it. So if I were a total rock star, I'd be like, well, whatever, you're never going to catch up to me, I got a PhD, But there is so much work to go around, and I care about the community. I can't do my job without a whole team of other people I could ask questions of, I can work with, who see things that I don't see, who look at things in different ways. So I actually really, really hope you're all interested enough in security to learn just a little bit, because we need you. So before we talk about how to do security in open source, how to test things, how to break things, what to do, I'm going to remind you that the most important thing in security is consent. So ethical security starts with consent. You want to work with projects that want to work with you, otherwise you end up with Oracle cease and desist letters. You might even want to be a little more picky than that. Like we want to find projects that have more time to work with you. So like if I wanted to work on Django security, there's a bazillion people who want to work on Django security. It would take work to get up to that level. But if you want to work on Mailman security, let me tell you, Mailman, most of the security bugs are fixed by one guy. His name is Mark, he's awesome. But we love it when we have help. And so you want to, if you're just starting out, you probably want to look for sort of those middle of the road projects that care, that are interested, that want to improve, but also are willing to spend the time with you and have people around. And you want to make sure that you know what you're working on stuff that you own. You're not breaking people's web apps. Please do not knock GitLab over again. I need it. You want to play by the rules. And when you're doing things like pen testing, you often establish ground rules before you even start so people know what's in scope, what's out of scope. So it's a practice that you should get in the habit of really early, is establishing what consent means, where the boundaries of what you can do and what can't you do are. This is I'm sure there are entire courses in this, but think about it. Think about it before you start. So one of the fun things about security is that security bugs are just bugs. I'm pretty sure everyone here has filed a bug, fixed a bug, found a bug. You don't really need a PhD to be doing this. You don't even need a little bit of a course. You could just like grab some tools you found on the internet and see how they work and see what you find and learn from there. So there are a bazillion security tools. Like really, there's lots of them. There's lots that are really good. There's a few that are really bad, but there's a lot that are really good. And which one you use depends on your context. So when I was trying to decide what to put on the slide, what I did instead is I put up two that I think would be really fun to play with that I know practically nothing about. So Google's open source fuzzer is a fuzz tester. So a fuzz tester is a piece of software that throws garbage into all of your input ports and sees what falls over. Sometimes it throws structured garbage, so it doesn't waste too much time, but it's garbage. And Google's has a really nice thing where it can set up for continuous integration. And I really, really want it to work on Mailman, because I think we run software that is fairly important to open source communities, and it should be really secure. So I put that one up there because if you're interested, I'm going to be at the dev sprints. You should come over, and we can figure it out together. I'll be terrible at it, but so will you. We'll have fun. Another one that I haven't tried yet is SonarQube. So this is static analysis software, which means it traces all the possible code paths and tries to find things that don't look right. Things that could be exploitable, things that could be sketchy. SonarQube is neat because it's open source. It doesn't have as many rules as the closed source alternatives. The one that open source people often use is scan.coverity.com, which offers free scanning to open source projects. But I really want to try SonarQube because it supports Python, and it's really easy for me to make it better if I want to do it. So if you're really curious, once again, I'm going to be at the dev sprints. I would love to learn this. I will not be able to teach you very well, but we can figure it out together, and it'll be really fun. So some people don't like just jumping in. That's fine. You don't want to look awkward. You don't want to be in this situation where you don't quite understand the lingo. So there's other ways to get started than just trying. So security has a lot of games. So I've listed a couple here. The first one is sort of a made for beginners, capture the flag type game that you play through the web page. It's fun. You go, you finish one challenge, and you find the clue that takes you to the next challenge. It's like a little puzzle. The next one, because I'm a web security person, this is Google Gruyere, which is a vulnerable web app that Google has put some lessons around. And the last one, I am totally being self-serving, is my own project, which we did based on Google Gruyere, intended to teach little girls, like 8-year-olds, web security. And I think it's super fun because all of the web security exploits we do just turn the web pages all sparkly and put rainbows and unicorns and stuff in them. And when we did this at a hackathon for a group called Chick Tech, and everyone was like, oh, this is great, the girls will love it. But the secret is, this is real exploit dev stuff. And I tell you this because when you find web exploits, sometimes the people don't believe you. So a friend of mine found an issue on meetup.com, and he had been trying for weeks to get them to believe that this was real. And I said, we can fix this. Come on. So what we did is we wrapped his, he didn't want to have a malicious exploit, so he just had the usual, XSS, it pops up a button, you click it, and it's fine. And they were like, okay, well, that's not a big deal. But when we made it so that HTML snow was drifting beautifully over your entire participant list and you couldn't sign up for anything, then they believed it. So, if you're reporting a security vulnerability and you want to make it clear but you don't want it to be, malicious, just pasting unicorns and rainbows all over someone's corporate website is totally legit. This is real security development, and we teach it to 8-year-olds. But it's a skill that doing very obvious things in web security is something we're kind of bad at, and it is a really useful thing. So even though that one was made for children and it's very silly, you might enjoy it, and it's a skill you might use later. So I could go on with a bazillion possible things, but mostly, if you want to find a tutorial, just search for a tutorial. If you don't like the first one you find, try another one. Security people love to share information. It's a surprisingly collaborative community, given that we also are super competitive sometimes. But there's a lot of people who are interested in, making security easier to understand. So there's lots and lots of tutorials. You can always find something that will work with you, and don't feel bad if the first one doesn't. The other thing that we actually make use of even at work, even though I have a PhD, I still take extra courses, is Coursera. And there's a bunch of universities in the US, in Europe, that do fairly good cybersecurity courses. If you're going to do it with a friend. It's very easy to just forget to finish your course or not do anything, or get partway through and your instructor keeps saying simple query language instead of structured query language, and you're so mad that you just can't do it anymore. Language, it's funny. But find a group. And really that's a lesson for security in general, is find a group. So one of the most fun things I did teaching security was when I was working in the Carleton Computer Security Laboratory. One of my coworkers, who was a master's student, I was just starting my PhD and doing the security stuff, said, "How long does it take to find a web exploit?" I'm like, "Well, what's a system we both have legit access to? Let's find out." So it turned out we both had access to our assignment submission system for the university. We did not really think about consent, and we should have, but thankfully nothing terrible happened to us. It took half an hour. He was a Windows guy. His specialty was in illegal memory accesses and security related to that. Half an hour, we were like, oh crap. I now know how to make it so the prof or the teacher who looks at my assignment has arbitrary code executed on their machine if they're running IE. So that sort of sucked. Thanks. And then we were like, okay, how do we report this? What do we do? It was a very educational experience. Maybe not the best one, but yeah. It used to be that it really was that fast to find web exploits. Thankfully, thanks to good frameworks like Django, it's a lot harder now, but sometimes you get a little bit lucky or unlucky, depending on how you see it. So another thing you can do, both with and without training, is threat modeling. So this is the process of imagining all the reasons that people might want to attack your software, how they might get in, what they might want to access, what they might want to do. And this is something that people take entire courses in. I took one last year. It was pretty good. But the thing that really resonated with me in my course last year was that this doesn't have to be something that the security person comes from on high and says, this is your threat model, you need to fix these things. It actually should be a collaborative process, because your security expert often doesn't know the architecture as well as your architect. And they don't know your users as well as your usability people. So you really want to get all those people in a room and collaborate. So if you're interested in threat modeling, we've got these great dev sprints. Sit down with a bunch of people, brainstorm, write some things down, drag me over and ask me if I can think of anything else. Sometimes I can, sometimes I can't. Drag other people who barely know your product over and talk about it. And threat modeling is really important because it's usually how we decide where we need to put extra barriers in place, where we need to put focus on places that are more dangerous and more likely to be abused. So this is sort of step one of security, and it's something that you can do completely untrained, and you'll just get better at it as you explore it. So it's worth just thinking about it for products you use, like how do people attack this? Why? And one that people don't really like to hear, but please write tests. Oh my goodness, please write tests. So I work in a fairly small group, and we are often hiring, although not right now. And one of the times we were hiring, my boss said, okay, you know what? There aren't that many people who are open source security experts who are on the market. So if you got any friends who are in open source or security, we'll try to train the other way. And a couple of the people that we've hired, who are now my coworkers, came out of QA, and they are the best at this. Those QA people know how to break a thing, know how to break a thing consistently. Maybe they don't know how to exploit it in a security context, but it's just, the mindset is really good. So if you're not sure how to get started, practice writing tests. Take something that's a good test and say, how do I make this terrible? Let's put 30,000 slashes in my last name and see what happens. That's basically what fuzz testing does, only you can do it more intelligently if you have an essence of what might be a problem. So it's a thing that's worth doing. It's a thing that improves security. And even if you don't care about the security aspect of it, having tests to show that the software is working correctly and we don't regress into old bugs is a big deal. And there's a bazillion other things you can do, but I've already been given my 10-minute warning. So the last thing I'll say is that it's worth spending a little bit of time to learn what's considered to be security best practices. So like, the number one thing in Python is probably going to be input validation. So you get some user input, you parse it in some way, something unexpected happens. So just like the 20,000 slashes in your name, think about what does good input look like, what does bad input look like. Exploring that will fix a lot of bugs. Another thing that obviously I care a lot about, because I spend a lot of time looking at individual components, is that people choose components intelligently. It's really easy to just like import whatever and never look at it. How do I know? Because I have gone to these things. So we've got a new product. They say we've got these 10 libraries. Please go and evaluate them. And I open it up, and the first thing I see is this library is not secure, or this library has a known vulnerability. I had one which was an iOS library that said, use of this library will get you banned from the App Store. What? Why? Why were we shipping that? Why did anyone ever want to ship that? And it's because, you know, it had probably been good 10 years ago, and nobody had checked. So, you know, when you do the import, just go and look at the first page of the website. If a product has known issues, people are quite happy to tell you often. So think about what you include, why you're including it, why it's meaningful. Don't get blinded by just pulling it all in and having the magic happen if you care about security long term. That's fine when you're just trying to prototype, but we all know that that little prototype is the thing you're shipping 2 weeks later. So be aware that it's an issue. So I don't know that I can answer the question. Is open source software more secure? Sometimes. It's not a very satisfying answer. What's much more satisfying is I can tell you that will open source software be more secure in the future? We can predict the future. Yes, it will. We've got a good base, and hopefully we've got a whole lot of help. Thanks.
So if anybody has questions.
So you mentioned about a threat modeling. Can you recommend any open source tools for threat modeling, specifically for the open source software?
There are a bazillion schools of thoughts in threat modeling. Actually, probably what you want to do is grab a couple of books. I honestly don't know which one I would consider the best, because I change my mood depending on what product we're doing, you know, different threats, different approaches. But probably what you want to do is don't worry so much about the tools, but read up on how experts think about threats and start there. And honestly, when I do threat modeling, we literally just open a Google Doc and let everyone in the room have access to it, and then just type over each other while arguing loudly about whether that's possible or not. So the tools maybe don't matter as much as the theories behind it.
Okay, thanks.
Any more questions?
You can also ask me questions about GSOC if you want.
So I want to try and be the devil's advocate about cease and desists for a minute and just get you to comment on that a little bit more. So you mentioned that Oracle would send you a cease and desist saying that...
They don't actually send you cease and desist. They just sort of hint that that could be a possibility.
Right, right. And what I'm trying to get at is maybe they only hint at it because they're probably required to do that, because if you don't defend your license agreement in any way, it kind of becomes as if you're invalidating your own license. Do you think that could be the case?
The whole issues of lawyers and trademark laws is probably beyond my capabilities. I think really, if you're producing these licenses, you should include clauses for that, because it's a part of being a good software citizen and being able to work with other people, that I think it's something that should be part of those so that they aren't put in that position. Yeah. I can't speak to whether they are in that position. And I can definitely speak to like, so academia is actually really terrible about security bugs. If I find a security bug, and I have, in code that's being used for research, you never report it. You never talk about it publicly, because you might have just invalidated someone's thesis, right? Like if I can't prove that the data server they were working on was not corrupted, so we just never talk about it. It's just magically swept under the floor, and everything's quietly fixed, and you run the data again. And so there's a lot of social motivations around security that openness and culture can help with, but it's something to be super aware of.
Thank you.
Any more questions? So I guess...
We've got one in the back.
You got one?
Cool. Yeah, so some of the points you mentioned about the community being important to the quality of the product, this is related to that. So the Linux kernel community has been getting a bad rap for being, not
They
very...
have been earning a bad rap. Let's be fair.
Yeah, well, right, yeah. But, so I want, but the thing is, Linux, you probably studied the security of the kernel, it being such an important piece of public,
Yeah, so the kernel is actually one of many products like Django that we just assume the community will do a good enough job because they've been consistent in doing that. There's lots of ways to
I was specifically wanting to compare the metrics you mentioned for judging the community and how well they apply to Linux versus the quality of the product that they release.
So when I'm judging something for work, we really, the thing we're trying to predict is how quickly the community will respond. I don't care if they're a bunch of jerks, as long as they fix their darn bugs. And the Linux community has shown very consistently that being a jerk does not stop them from fixing their bugs. It probably stops them from attracting top talent, but they have such a wide pool that it doesn't matter to them. And that's good enough for our purposes. I have to say that if it didn't have such a wide pool, I do think they would have problems. Smaller projects that have culture fit issues do tend to drive away contributors who would make them better. But certain projects are just big. They have a big pool. They don't care if they lose a few people. It sucks. I wish I could tell you that being nice would make your security better, but that's not true.
Thank you.
So, does anyone has more doubts?
Yep. I have one question.
We've got one more back here, too.
Yeah. Terry, thanks for the talk. It was definitely informative. I have a question. Maybe it's based on the bias that is there in everyone's minds. The common argument around open source definitely being more secure than closed source is that there's a lot of code review and design discussions that happen around. So when you have many people like experts putting their thoughts to solving a problem, the possibilities and the probability of something being found, like a security vulnerability being exposed early is higher than what would happen in a closed source where the same team works on the software and it's the same set of thought process that always drives the development. So what does your research say about this? Like, is this a myth or is it just, like, is it true?
So this is actually a literal textbook example. John Viega, who wrote Mailman, the original version of Mailman, talks about it in one of his security books about how he had always thought, you know, that you'd have this huge community, it would be fine. But Mailman, when it was first written, Python wasn't a super popular language. And so they had a community, but they didn't have the right people. And so we had a security bug early on. I can't even remember what it was. It was before I joined the project. That persisted for ages because it wasn't the right eyes. And that's one of the reasons that I like getting up here and talking about it and encouraging you all to learn a little bit about security, is to make sure we have the right eyes looking at the project. I don't know that proprietary software necessarily has the right eyes either. So my intuition is that the populations are similar, but because we have a bit of a culture thing around security and wanting to show that we are the best, I think we have an edge, but that doesn't always, I mean, it's a population thing. Sometimes that works in our favor and sometimes it doesn't.
Okay. Thank you.
Okay, so I had a comment on funding on open source projects. You mentioned that a lot of companies actually fund open source projects and open source project security, but then Heartbleed, for example, among all of the things that it demonstrated, it also demonstrated the fact that a very, very important project like OpenSSL was severely underfunded.
Yeah, and this is true in the proprietary world too. I can't tell you about the products we have at work that you would think would be funded but are actually one dude.
Right.
It's not unique to open source, unfortunately, and it's sad. I think we're starting to see those gaps, but we're certainly not finding all of them. And because I've reviewed so many packages, we had some that were like core Red Hat packages that basically no one had touched since 1999. My favorite one was one where when I went to look up the source code, there was a note on the page from, I don't know, 2001 or something, saying, so yeah, this code was kind of on a compromised server, and we don't really know if it's legit, but we've all been using it, so we're good. So we have a lot of stuff like that. It's really embarrassing. Maybe we'll find them all eventually. I mean, it's one of the reasons that Intel doesn't release the work that we do on scanning projects, because there's a lot of embarrassing little things that it's not polite to tell the world that we know that these things are bad. But I think we're getting there. It's a long process. There's a lot of projects. There's always going to be stuff that falls through the cracks. But I think the higher profile bugs and the greater security awareness is pushing us slowly towards, we're getting to the point where we're going to be able to say yes.
Yeah, I just wanted to make that comment in favor of bug branding in many ways, because it kind of shows us, or it reminds us that we probably need to put more funding into a lot of these important projects.
Yeah, it's pretty useful.
Thanks.
Oh no, Stephen's going to troll me.
No, I'm just going to distract you from Mailman. There are no bugs in Mailman.
Yeah, I don't see you merging code.
No, you don't. So I've talked to a bunch of people who were big XEMX users, and they said, I'm sorry, but we can't show you our proprietary extensions. And it doesn't bother me that those extensions are proprietary. What bothers me as an open source developer is that those are extensions, and they're done by other people that I have no control over. I don't know what they're doing. And this is a designed-in threat in open source development. Comment.
I don't really know that we have a good way to solve these things. Like, we like things to be interoperable. We like people to be able to tweak them. And that means we're leaving a lot of possible holes. It's a value judgment. I mean, So security people love to rag on IoT. There's a lot of terribleness. People are trying to get fast to market. They don't care about security. Or they claim to care about security, but they're lying. Believe me, I've heard a lot of, well, we care about security, but we can't actually give you another tester. So all of these things, you're making value choices. So in IoT, sometimes you care about it being fast, and you make a bad decision. Sometimes you care about providing extensions, and you make, maybe, I shouldn't even say it's a bad decision. It's just a decision that you should be aware has consequences. At this stage, the best we can hope for is that people are aware, people think about threats, people think about how we do it. Long term, maybe we will get to the point where we think about it before we make the decision to put these holes in. I don't know. I really don't.
Okay.
We got one in the back if we still have time.
So we don't have time, but
Oh, we don't
I
have
guess-
time, apparently.
Yeah.
We should talk later then.
Yeah. So we should give a big round of applause for this talk. And so now we'll be moving to the feedback session, which Kushal.
Actually, there is something more. So, okay, so just before we start the feedback session and before the feedback